بسم الله الرحمن الرحيم رب زدني علما.
The next thing, we'll try to see troubleshooting with static IPv6 routes. Now, in the previous section, we have already seen the troubleshooting the IPv4 routes. So when it comes to IPv6, the steps remains the same. So there's no much difference in between them, but there are slight few differences we need to check, like verifying the link local addresses, and there are a few different options. So again, just like normal static routing, we need to make sure that the static route is correctly configured. That's important. With a proper ID, that is your destination network ID, and the prefix, which is a replacement to the mask, it should be correct. And also make sure that the next hop configuration is also correct. And also we need to make sure that the next hop should be valid. And for that, we need to verify the WAN connectivity here. Now, just like normally there are two possible issues with the static routing. So either you see the static routing is configured with incorrect routes, like incorrect means maybe you have configured the wrong destination address, maybe the prefix length is wrong, or maybe the next hop address might be wrong. So you see the routes in the routing table, but it was misconfigured, it is incorrect. And the second possibility is you don't see the routes at all in the routing table, even though the configurations are correct. So the first thing we'll try to see incorrect static routes. So what are the possible things we need to check with IPv6 when it comes to incorrect static routes which appears in your routing table? So the first thing, we'll start with the prefix length. We need to make sure that the configurations, what we do, the prefix configuration should be correct. Means when we configure, if you check this first example here, we need to make sure that we configure that particular subnet and the prefix length, everything should be correct. So as per my topology, if you see here from the router 1, we are trying to write a static route for this subnet. And as per the configurations here, if we just try to see IPv6 route, let's assume this is our example. And here there is a wrong prefix given here. So as per our example, the destination network ID should be 2001 DB89:3. But here it is something like 33 written here, which is a kind of typo error, might be a typo error, or maybe you have seen 33, maybe 23, sometimes it happens. So as per this example, the subnet ID is actually wrong. The prefix seems to be okay, no problem. And also if you verify the next hop address, the next hop address anyway, I don't see in the right now. In here you can see the next hop address here, 2001 DB8, and this is correct. So the problem can be with a wrong prefix length, or maybe a wrong prefix, or maybe a wrong prefix length, or maybe the next hop issue. Now the next thing, if you are using the next hop IPv6 address, if you are using a link local address, then make sure that you are using the correct link local address. Like if you check this example here, the second one in this example, so we are trying to write a IPv6 static route from here to here. And if you try to see, the destination network ID seems to be correct, and the prefix length is also same, and the exit interface, because whenever you're writing the link local address as a next hop, we must define the exit interface, and the exit interface seems to be okay. But again, the link local address is not the correct one. So this is your next hop link local address, and it should be this one, but it is misconfigured with this address. So probably that is another issue where we have wrong neighbor link local address configured. Now the next thing is, if you're using a next hop IPv6 address, then like next hop IP address, if you're using any unique local or the global unicast address, it should be correct. Like if you take the first example here, so in my example, this one, and if you try to see, the destination ID seems to be okay, and the next hop link local address is also okay, this is also okay, but there is no outgoing interface, because whenever you are writing a link local address as a next hop in IPv6, you need to make sure that you also define the exit interface, which means it should be something like this. So you can see there is a missing outgoing interface when you are using linked local address. Of course, this exit interface is not required if you are using the next hop IPv6 address. But if you're using any linked local address, then you must define the exit interface also. So these are like general problems or general misconfigurations you will see. Now, one more thing we'll see, if you are referring to any outgoing interface, then we need to make sure that IPv6 route command is referring to the interface should be a local router. It means that here, if you just try to see here in this example, this one. So from the router 1, we do have a prefix. The prefix seems to be correct. And this should be the next hop IPv6 address. So as per my topology, this is 1, this is 2, and you can see this is actually wrong next hop. Because when you're writing the next hop IPv6 address, it should be the IPv6 address of the next router. So that is again another possibility. Now, one more issue here, you can see there is IPv6 route configured, and here you can see there is a wrong interface given. Because from the router 1, we are using linked local address. The linked local address is correct. The next hop linked local address as per my topology. And the destination prefix seems to be okay. But the exit interface should be G0/2 as per my topology, but it is wrong. So these are some of the common misconfigurations what you will see with the static routing in IPv6. So you need to make sure that depending upon what type of configuration you are doing, you need to make sure that this configuration should be correct. So if you are not able to see a specific, if you generally see the routes in the routing table, but if they are misconfigured, now these are the things we need to check. The next thing we'll also see, what if the routes are not at all seen in the routing table. So like we will say that, okay, let's assume that the configuration seems to be perfect. Whatever the configurations, they are correct, but still the routes are not seen in the routing table. Then what are the things we need to check? Now, just like IPv4, so we need to make sure that the next hop should be up and down. Because whenever you are writing a static route, so it's very important that when you're writing a static IPv6 route, let's say this is my destination network and this is my next hop, and this interface should be up and up. Because if the interface is down, then automatically the next hop route will not be seen in the routing table, which means the next hop becomes unreachable. And any route which is having invalid next hop, means if the next hop is not reachable, then automatically that route will not be installed in the routing table. So this rule applies for whether it is IPv4 or IPv6 or any kind of routing. So we need to make sure that the outgoing interface should be up and up. That's a main thing. In our case, again, as I said, when you're using the global unicast address as a next hop, or if you're using any linked local address as a next hop, basically you have to ensure that the next hop should be reachable. And one more thing we need to check, in case if you have multiple routes, like in this example here, let's say from the router 1 to reach this particular subnet, or maybe from this router to reach this particular subnet, you have multiple routes here. So we have this route, and then maybe on the router 3, you have configured this route, let's say. So if there is any multiple routes exist in your network with the same prefix, same length, we need to check the administrator distance, because sometimes what happens is when you configure a specific static route on this particular path, let's say with the AD value of 1, or maybe you have configured with AD value of 10 here, maybe. And if there is any alternate route with a better AD value, it will start preferring that route. And maybe that is misconfigured. So if that route is misconfigured, maybe there is no route from this side. And actually it will try to install from this next hop. But to reach this particular destination, there is no route at all here from here. So we need to always ensure that the next hop should be valid. That's the first thing. And if there are multiple routes, then we need to make sure that the actual path to reach that particular destination should have the least AD value.